Light speed is more than just a number. It's a fundamental constant, a cosmic speed limit that governs the very fabric of our universe. Understanding light speed unlocks secrets about how stars shine, how galaxies form, and even how time itself behaves. It's the key to unraveling some of the biggest mysteries in the cosmos. Imagine the universe as a vast cosmic highway. On this highway, light speed is the ultimate speed limit, a barrier that nothing can surpass. Just like the rules of the road govern traffic on Earth, light speed dictates how energy and information travel through space. This speed limit isn't just a theoretical concept, it has profound implications for our understanding of the universe, influencing everything from the way we communicate across vast distances to the very nature of causality itself. By exploring the nature of light speed, we embark on a journey to understand the fundamental laws that govern the cosmos. Buckle up because things are about to get fascinating. Light travels at an astounding speed, approximately 186,000 miles per second. To put that in perspective, imagine circling the Earth 7.5 times in a single second. That's how fast light moves. This incredible speed is why we see things almost instantaneously. When you flip a light switch, the room appears to illuminate instantly because light travels so quickly. But even at this mind-boggling speed, light still takes time to journey across the vast distances of space. The light from our sun, for example, takes about 8 minutes to reach Earth. This means that when you look up at the sun, you're actually seeing it as it was 8 minutes ago. You're looking back in time. Science fiction often tantalizes us with the idea of faster-than-light travel, but the reality is that exceeding light speed is a much trickier proposition. The laws of physics as we currently understand them put a firm stop sign at light speed. One common misconception is that we just need to build a powerful enough spaceship to break the light speed barrier. However, Einstein's theory of special relativity tells us that as an object approaches the speed of light, its mass increases infinitely, making further acceleration impossible. Another idea is to find shortcuts through space-time like wormholes. While theoretically possible, wormholes remain firmly in the realm of speculation, with no current scientific evidence to support their existence. For now, exceeding light speed remains a distant dream, constrained by the fundamental laws that govern our universe. Here's the thing about light speed, it's not really a speed in the traditional sense. It's more like a property of space-time itself. While objects with mass are bound by the rules of special relativity, light, being massless, plays by a different set of rules. Think of it this way, light doesn't accelerate to its incredible speed. It simply exists at that speed, always has, always will. It's woven into the very fabric of the universe. This is a fundamental difference between light and everything else in the universe. While we can accelerate objects with mass, pushing them closer and closer to light speed, though never reaching it, light itself is fundamentally different. This unique nature of light is what makes it so fascinating and why its speed plays such a crucial role in our understanding of the cosmos. Section 5. Einstein's big idea unveiling special relativity. Albert Einstein revolutionized our understanding of space, time, and gravity with his theory of special relativity. One of its key postulates is that the speed of light in a vacuum is constant for all observers, regardless of their relative motion. This might sound strange at first, but imagine this. You're on a train moving at a constant speed, and you throw a ball forward. To you, the ball appears to be moving at a certain speed relative to you. However, to someone standing on the ground, the ball appears to be moving at the speed of the train, plus the speed you threw it with. Einstein realized that light doesn't work this way. No matter how fast you're moving, even if you're traveling at close to the speed of light yourself, light will always appear to be moving at the same speed relative to you. This realization had profound implications, leading to the concepts of time dilation and length contraction. The idea that time and space are not absolute, but are relative to the observer's frame of reference. Section 6. Quantum quandaries, challenges to the speed limit. Even with our current understanding of light speed, there are still mysteries to unravel, especially when we delve into the realm of quantum mechanics, the study of the very small. Quantum entanglement, for example, presents a particularly intriguing puzzle. This phenomenon involves the strange connection between two entangled particles, where actions performed on one particle instantaneously affect the other, regardless of the distance separating them. This instantaneous connection might seem to violate the speed of light limit, but it's important to remember that information transfer still appears to be bound by light speed. While quantum mechanics challenges our understanding of the universe in fascinating ways, it also highlights the importance of continued exploration, and the possibility of even more profound discoveries yet to come. Section 7. Proof in the pudding. Evidence supporting light speed supremacy. Over the past century, numerous experiments have confirmed the constancy of light speed and the validity of special relativity. These experiments range from precise measurements of the speed of light in different reference frames to observations of cosmic particles called muons. Muons are created high in the Earth's atmosphere by cosmic rays. They have a very short lifespan, decaying rapidly. However, because they travel at close to the speed of light, we observe them reaching the Earth's surface, a journey they shouldn't be able to make given their short lifespan. This observation can only be explained by Einstein's theory of special relativity, specifically the concept of time dilation. From the muon's perspective, time slows down as it approaches the speed of light, allowing it to live longer and reach the Earth's surface. This is just one example of the overwhelming experimental evidence that supports the constancy of light speed and the profound implications of special relativity. Section 8. Light speed's enduring legacy, shaping our cosmic perspective. The speed of light is more than just a number. It's a fundamental constant that shapes our understanding of the universe. It tells us that information cannot travel instantaneously, that the cosmos has a speed limit, and that time and space are intricately intertwined. As we continue to explore the universe, light speed will continue to be our guide, helping us unravel the mysteries of the cosmos and pushing the boundaries of human knowledge. It reminds us that the universe is full of wonder, and the more we learn, the more we realize how much more there is to discover. So the next time you look up at the night sky, remember the incredible journey light has taken to reach your eyes, carrying with it secrets from across vast distances and reminding us of the awe-inspiring nature of our universe.